Hello, everybody, and welcome to Startup.Security's OSCP training. My name is Siren. Many know me as a practitioner and teacher in the world of information security, providing methodologies for penetration testing. Additionally, I'm the co-author of the OSWA certification and have had the privilege of educating and certifying many ethical intruders around the world with my methodologies. Being that this is our introductory module titled Network Enumeration, we should have a few things already in place and ready to go. For one, we should have our own VirtualBox instance running the latest Kali Linux image. In addition, we should also have Metasploitable 2 running in a separate instance and off of the same network. Please note that the Metasploitable 2 image is an extremely vulnerable machine and should be closed when not working on the course practice. Once both Kali Linux and Metasploitable 2 are running in parallel, we can begin with our terminal full screen as we have it here. One last thing to mention before we begin is that it is stated at the time of registration that students must have a prerequisite knowledge of Bash, TCP/IP, and Python. You don't have to be a wizard with them, but please be familiar as it will help you tremendously towards understanding my methodologies and how we do things. With that being said, let's go ahead and get down to business. So with all the introductions out of the way, you're probably wondering, Siren, how do you get your setup the way you get it? First things first, in this course, we're going to be working with Bash. That's short for the Born Again Shell. BASH, all the way. Natively, I do believe Kali Linux will come with Z shell or .zsh, but again, we will be utilizing Bash, legacy Bash. And to do that, we can use a built-in program called Kali Tweaks. It comes with Kali Linux. And if you type in Kali Tweaks and go ahead and hit the return key, you'll get this big screen that pops up. What we want to do is go down to shell and prompt and hit the space bar, actually shell prompt, right arrow, hit the select there. And we're going to do two things. We're going to be configuring the prompt and the default login shell. So the prompt, if you want it the way that I have it, is going to be kind of like this. And you'd probably want to do this. So it's going to say, failed to parse shell configuration. That's okay. The following config files will be replaced. You may not have to get that at all. But if you go to configure prompt, what you want to do is you're probably just going to get this, right? I already had it set. So I want it to be one line. So I'm kind of going in parallel with you. But 2 lines down to 1 line. We want a 1-line thing, a 1-line situation here. That's going to allow more information to be displayed on screen, right? So for all the output, we don't have 2 lines, but we have 1. And we'll click Apply, setting to 1 line, spacebar, set OK. And the next thing we want to do is set the default login shell itself from ZSH to Bash. Yours might already have an asterisk. For ZSH, just make sure it's Bash. Go down to use that right arrow on your keyboard. Go down to Apply, spacebar, and then you can click back and right arrow, spacebar on Quit, and that's it. That is it. I'll clear the screen. And what you can do additionally, if you'd like to be extra fire and extra quick, is you can essentially, hit F11 at any time to bring this to full screen. So you can open your terminal. This is what we're going to talk about next. You're probably like, my terminal doesn't look exactly like yours, Siren. Why is that? The answer is simple. I'm using something called Terminator. Some people use Tmux, and other things. I use Terminator. Why do we use something like Terminator? The reasoning is simple. Because it allows us to have additional functionality that a traditional terminal might not allow us to have. In fact, your terminal might be looking something like this. Look familiar? We want to get out of this. So what you want to do is sudo apt-get and install -y for yes Terminator. And punch in your password. And it'll go, it'll fetch it, it'll download it. And that's all there really is to it. That'll download and install Terminator. Wonderful. So that's gonna be Terminator installed, and we can exit out of these. How did you get all of those windows open side by side? Well, with Terminator opened, and this is what I want to show you, something really cool. You can go to the top left here under Applications and type in Keyboard, and then click on Keyboard. And this will just make you extra quick with things. But what you want to do is go on over to Application Shortcuts, and then scroll down to the bottom if you'd like. Mine should be here. Here it is. Perfect. Shortcut is set to Control-Alt-S. I just hit Control-Alt-S with my left hand, and that opens Terminator. You would do that by clicking Add down here, and you could type in the command that you actually want to trigger. In this case, we want to open the binary executable file, or the binary file called Terminator. Once we've installed it, we want to open it, right, with a shortcut. So we type in Terminator there and hit OK, and it'll say, great, what key combination is going to open up your Terminator really quickly? This is personal preference to the nth degree. This is something like you choose this, whatever you're going to be familiar with. I have Control-Alt-S. You're free to use whatever you like. That being said, you would hit Control-Alt-S, and that's all. I'm going to cancel out of this because I don't want to have duplicates. But, in fact, I'm going to have to delete this duplicate so that we have one entry here called Terminator is the command, and the shortcut, for me, it's Control-Alt-S. You can have it to whatever you like. But now I can close out of this, and we're down here, right? We just have our desktop open. We just logged in, and I can hit Control-Alt-S. Boom. F11. Full screen. I want to open up another terminal. Control-Shift-O. And that splits the screen across horizontally. I want to open another terminal. Control-Shift-E. I want to open another vertical split up here as well. Control-Shift-E. And now we have 4 terminals, full screen, ready to rock with Terminator. We can hit exit, exit, and exit. Your Terminator might look different. I want you to know that you can go down to Preferences, and you can do all kinds of things here. You can hide the menu bar. You can set your cursor however you like it. There's a ton of things that I encourage you to look at, but we want to look at Profiles and then the General tab. I have my font set to be monospaced. So monospace regular 14, right? We can even change that to NOTO, Noto Mono. Kind of sounds funny, but Noto Mono bold at 14 pixels in font size, allow bold font. And I have show title bar unchecked, and I just have my background set to black. Excuse me, my foreground set to black here, my background set to red. And as far as the cursor is concerned, I have it set to an underline. But there is a block. You can do an I-beam. This is that blinking cursor type thing. It's all personal preference from here. You can go from here to scrolling. Make sure that you have your scroll bar on the right side. That's what this is over here, so we can see our scroll bar. And then check the box that says infinite scroll back. This means that we can constantly scroll back, and it's not going to purge any of our output. So that's an important one there as well. Then under background, you can set this to maximum, or you can set this to solid color, and it'll be pure black. And then here, built-in schemes, you can do white on black, or you can set this to custom and have that be white on black, and everything is pretty much the same here. I encourage you to play with your colors, get it however you want, get it vibrant, have fun with it, enjoy it, because we are going to be in the terminal a lot, like a lot. And with that being said, let's go ahead and close this out, and we're ready to move on to the basics of networking, actually. So, first things first, let's go ahead and check out our network, right? What IP address have we been assigned? So first thing we're going to type is ifconfig, or ifconfig. And here we go. We have an ETH0 interface. We have our INET as 192.168.1.233. That's our private IP address space. We additionally have a net mask of 255.255.255.0. I want to make something abundantly clear here with networking. This is known as a Class C range. So a Class C range is going to be anything that is 255.255.255.0. That's going to be a net mask of 255.255.255.0. A Class B range is going to be anything that is 255.255.0.0. And if you can identify the pattern here, a Class A IP range is going to be 255.0.0.0. So these are like the big guys, right? Think of like Google as 8.8.8.8. That's, falling into these bigger ranges, right? Class B ranges, upwards of, and this, don't quote me on the accuracy of this exact number, but it would be, last I checked, upwards of 67 to 70,000 machines, just in that range. A lot of computers, a lot of machines going from a Class C range to a Class B range. Now, on a Class C range, we have, as you might have guessed, about 255 computers that can exist assigned via DHCP to that range. So now that we know that our DHCP assignment is .233, and for you, the student, this will be different, and that's perfectly okay and perfectly expected, what we're going to do is try and discover any machines that are running on .1.0 through 255. And you might think we're going to do this with Nmap first, but we're not. Let's clear the screen. We're actually going to be doing this with ping, and we're going to be using a ping script to do this. So first thing we're going to do out of our home directory, if we type pwd for present working directory, that's home Kali, we're going to make a directory called scripts. Then we're going to cd into the scripts directory. And what we're going to do is create a file. On Linux, you can create a file just by touching it. Touch ping_script.sh. So we've created the file. Now we need to permit the file for execution. chmod +x, that's executable permissions, on ping, and you can tab this out if you like, pingscript.shell. Great. Now what we're going to do is nano pingscript.shell, and I'm going to go over a little script. So what we're going to do is essentially just paste this in, and I'm going to review this for you. What we have is a shebang, bin bash, so we're invoking bin bash on this. And then we're going to say loop through all IPs in the range 192.168.1.0 to 192.168.1.255. In your home network, guys, a side note here, in your home network, this might be something like 10.10.1.0 through 255, and that's perfectly fine. That's considered private IP address space. That's what that is. So with that being said, though, however, here we have a 192.168 assignment, and we're going to be going through with that forward, at least in this course. So, or in this training rather. Now what we're going to say in bash is for I, for the variable that we declare I in the sequence of 0 through 255, do the following. We're going to say use the ping binary and send one ICMP packet. That's counts-c, counts of 1. And we're going to give it a timeout of 1 second so that we're not waiting forever. And we're going to say 192.168.1.$i, the variable I, which will increment. It's a simple for loop. It will increment by 1 each time and direct that output to dev null. Now we're going to check and see if the ping was successful. And we're going to do that by checking to see if $question mark equates to 0, right? Then this is online. Otherwise, 192.168.1.$i, that is whatever iteration of $i we're on, be it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever it is online or offline, right? And then we're going to say FI for finish and done. With that being said, we're going to go ahead. I'm just going to leave this open here. You can feel free to pause your screen if you like and copy this over. But I'm going to leave this for a couple of seconds, and then I'm going to save the document, and we're gonna run it. Okay. So assuming that you have this and you're ready to go, I'm going to hit Control X. I'm going to press Y on my keyboard to save the document, and then hit the return key. And now we're ready. So what we're going to be doing is executing this with ./ping_script.shell. This is the script that we're going to be executing, and we're going to be executing it with ./. Now we could say bash-c, and then ping script.shell. That's another way of executing it. But we're going to say ./ping script.sh. And yeah, then we'll go ahead and hit the return key. And we're going to let this go. So you'll see that it's iterating. .0 is offline. .1, there's a gateway. That's online. And then it's going to go through quite a while here, but 255 iterations, believe it or not. Which one of these is the Metasploitable 2 machine? Aha! There it is. 192.168.1.23 is online. Nice. Well, I'm going to go ahead and let this run and save you guys the time. So I'm going to just pause the recording here and then unpause once this script is done running. And we'll kind of talk and discuss this over. All right. And that's complete. And you'll notice up here that we have 192.168.1.233. That's us. We're online as well. So that took quite a long time to get, by using a ping script, that took a very long time, even with -w, the -w flag set to 1. That took ages to scan a Class C. You're probably wondering, Siren, is there a quicker way to do this? And the answer is abundantly yes. And there is a way with Nmap. So what we're going to do is go ahead and clear the screen. And our first Nmap scan is going to be a discovery scan. So we're going to say Nmap do -sn, all right, 192.168.1.0-255. And this -sn here is pretty much the same exact thing as a ping scan. It's just extremely quick. So let's go ahead and run that and see how much quicker that is compared to running a bash script that has, a ping iteration going through it. We'll hit the return key, and we'll see about how long, this will... Oh, goodness, it's already done. That was quick. So, in the professional or real world, you're assigned a Class C range and you need to do something stealthy, you need to do something fast, and you need to scan down that Class C range. Well, you use Nmap-SN, 192.168.1.0 through 255, or whatever you're permitted to, whatever Class C range that you're permitted to scan down. Hope that makes sense. In the next section here, what we're going to be moving into is actually, before we even go any further into Nmap, we're going to talk about Netcat, and we're going to do something really cool called Netcat Chat. A lot of people don't really know what this is, and that's fine. But this is something that really helped me when I was starting out to understand TCP/IP fundamentals. And it's something that I think is really critical that you understand and visualize by setting up your own Netcat server, your own server with Netcat, what we would call a bind server, and connecting to that server and establishing a TCP connection and watching the information as you type in it and chat back and forth in it being transmitted over the network. And that's basically what we're going to work on next. Okay, so at this point, basically, we're going to start talking about Netcat and what we call Netcat Chat. So I'm going to hit Control-Shift-O to open up a separate terminal. Up here in the top, we're going to have our server, and in the bottom, we're going to use Netcat to connect as the client to connect to that server. So I'm going to type NC. You can validate that Netcat is on your machine by typing which Netcat. That'll show you the location that it is, the location in which on Linux where the binary is present. Another thing you should know is that everything on Linux is a file. Your camera, your keyboard, your mouse, your connectivity, your browser, everything is a file on Linux. It's the basic premise of Nix-based systems that everything is a file. Hence, lots of configuration can be, made in lots of distros and so on and so forth. But in this case, we use the which command to determine where that executable binary is. That's in user bin netcat. And with, netcat being out of user bin, what we're going to do is type nc-nlvp on 9090. And what this is going to do is set up a server. So we're saying in numerical IP format, -L listen, V verbosely, P on port 9090. So NLVP, NC-NLVP 9090, listening on any 9090, and we've established a server. I'm going to hit F11 to come out of full screen here, and we're going to open up Wireshark. And then what we're going to do is go and just select the ETH0 interface. That's the interface for this virtual machine. And you can see we've got, typical traffic, but there's not really much happening here. Nothing really special at all. But we are going to make something special out of it. So we've got our server here listening, and then in the bottom, we're going to type ifconfig, and remember that we have our IP address here as 192.168.1.233. We're going to copy that, and we're going to export that as an environment variable. This is not required to do Netcat Chat, but it's a habit that we do want to get into going into the future. So we're going to export IP is equal to, and in double quotes, we're going to paste that in there. Okay? And now we can echo $IP and see that it is 192.168.1.233. Now we're going to clear this out, and we're going to netcat-nv net verbose to the IP on port 9090. And as soon as we hit the return key, we instantaneously have a connection. And if we look at Wireshark, let's go over here. we should see, oh, we don't, so I'm gonna have to re-record this. Or pause it. And what we're gonna do is press F11 to bring ourselves out of full screen. And then we're gonna go up here to the top left and type in Wireshark and open that up. And then we're gonna be listening locally off that loopback adapter, thinking local with that loopback adapter. And that's 127.0.0.1. That's local host. That is loopback, or LO is the interface. And we're going to listen off that. Now we are going to type ifconfig. Notice our IP is 192.168.1.233. You can also type ipconfig and grep-i for inet. And or grep, excuse me, if I type ifconfig. We can also type ifconfig and grep-i for inet. You can add color to that as well. -- color equals auto. Grep is an important command, and we'll get to that, later down the line with our enumeration. But for now, it's just basically like the find. If you're really not familiar, grep is just like find. So inet 192 find whatever we put in quotes in the output. So we can condense that and say, our IP is 192.168.1.233. Well, what if I want to export that as an environment variable? If you type env, that's in for environment. So the environment for, our shell, we have lots of variables here and values. Our shell is equal to user bin bash. That means if we echo $shell or $shell, we get back the value, user bin bash. We're going to do the same thing here. We're going to export IP equal to double quote, 192.168.1.233. And if we echo IP, notice this is just going to echo IP. If we echo $IP, we echo the environment variable. All right. So with that said and being done, and Wireshark listening on that loopback adapter, we're going to type netcat-net verbose here to the target IP on port 9090. And we're going to hit the return key or press enter. And we have a connection established. Awesome. So let's take a look at Wireshark. And we're going to be learning a few core concepts about attacking networks. And whenever we do remote internals, right, you want to be a part of a red team. You want to do a remote internal. You got to be sniffing those packets. You got to think like you're hacking off of their network, and their network is the local thing. These are the types of things we'd be looking for. HTTP clear text transport, so on and so forth. We'll talk about these later in the course. But notice how we have a SYN, a SYN-ACK, and an ACK. That is, these are the three stages of a TCP handshake. That's it right there visually. SYN, SYN-ACK, and ACK. So SYN, SYN acknowledge, and connection acknowledged. Pretty radical, pretty awesome, right? Let's show something even more radical and awesome. Let's say I'm the server, and this is Netcat Chat for a reason. And let's say the server and the client, which we need to be very fundamentally and have a good understanding of this, right? As attackers, a server and a client. Well, up here's a server. What if this was a mail server? What if down here was the mail client? So what we're going to do is we're going to go in here to the server and we're going to say, hey, dude, this is some information transmitted over an internal network and private IP address space. Cool. And then we're going to Alt-Tab, and if we look at the next packet sent, we see something different. happens, right click, follow that TCP stream. And in plain text, we have, hey dude, this is some information transmitted over an internal network and private IP address space. Cool. What if I'm the client and I want to respond to that? Let's say some other person. We could reply with, hey, that's pretty cool. I need to log in to the dev server. Do you have the creds or credentials? And notice how up here the server received that. Okay, let's go down. There's the information. This is all the hexadecimal that corresponds to the particular character or particular byte. We can right click, follow TCP stream, and well, goodness and gracious. This is starting to look a little bit like a chat room, isn't it? So a client and a server is really no different than the idea of a chat room. Information gets sent from the client to the server. The server figures out programmatically how it wants to reply, and it replies. Or it cuts the connection entirely. So let's say I'm the admin here and I'm on the server and I'm like, sure thing. Password for SSH on the dev server is some series of numbers, a couple special characters, and I don't know. Can't hack me. Right? And we send that along. And then we go back. We don't see that here. We close out of this. And we go down here. We right click, follow TCP stream. Sure thing. Password for SSH on the dev server is thank you very much. Right click, copy. And we've got it. Thanks, dude. And we can close out of this. Go here, and of course, we can see the conclusion of that. Thanks, dude. And we can close the connection. And then up here, delete our filter. Enter to apply it. We have fin acknowledge, acknowledge. The ending parts there of our TCP IP kind of conversation. And some very core fundamentals, right? Very core fundamentals. So we're going to close out of Wireshark now, and we're going to segue into doing some actual in-mapping and various types of in-map scans that I like to do. And I'm going to be walking you through them on the target Metasploit machine. So let's go ahead and get down to that. So basically now we're going to segue, right? And we're segueing. In fact, I'm going to close this bottom terminal. And what we're going to do is explore Nmap. This module is, network enumeration. If I'm, as a principal red team engineer currently, if I told you and we were authorized in a Class C engagement with a stakeholder, and I would want you to know this information, not only the networking information and TCP IP information relevant to determine where encryption is not present, but also per my methodology, I'd want you to have a clean scan of that network. I'd want you to know evasion techniques when doing that scan, and how to even just do your own banner grab without Nmap to a specific IP and a specific port and see what it replies with and how you can interact with it. And what we would refer to this as is all preliminary. I refer to this as preliminary or preliminary, but preliminary enumeration. So what we're going to do is recall that we were on .23 with Metasploitable. We can confirm that, by the way, nmap-sn to 192.168.1.23. Just pinging it, basically. Shouldn't take very long. And there it is. Nmap scan report for 192.168.1.23. Their Nmap is saying host is up. Great. Not only is the host up, but we're ready to rock. So what I'm going to do is export my target. Export IP is equal to 192.168.1.23. And I mean, this is the equivalent in my mind. This is the equivalent of exporting target equals 192.168.1.23. Like, that's our specified target. That's our in scope target right there. So now we're going to say nmap, and we're going to cover all ports. We want to make sure. Why is this important? Because, I mean, can I specify -- top ports 1000? Yeah. Can I specify 10,000? Yeah. But what if somebody like a systems administrator is clever? What if that systems administrator or developer has their developed service running off of an obscure high port like 63,219, and to make it blend in like it was an RPC port or something like that? Well, we want to do, for compliance as well, you might as well know -p- with your scans. You want to make sure that when you're scanning, you're covering all 65,535. That's 65,535 ports. So nmap -p-, right? And now we have a massive variety, but we're going to be focusing in on just some core ones. So first things first, let's try for firewall evasion and see what kind of output we get back. This is known as a fragmentation scan. I encourage you to check this out in Wireshark on your own and see how they vary. You know, what do they look like? But we can type in the IP there, or we can type in $IP. This is useful for cross-tooling. The reason we want to get into this type of thinking is that when I don't know, let's say you followed my streams, you know who I am, you know I have common. Let's say, look at all of these that rely on $IP, $IP, TCP dump, whatever, that one didn't have it, but maybe URL of the target web endpoint, an Nmap scans, $IP, $IP. So for any tool that utilizes an IP address, having it exported is extremely useful. So in plain English, we're saying Nmap scans 65,535 ports in the form of a fragmentation scan at the target IP, and we're not interested in closed ports. We're only interested in really scanning down open ports, and this will also speed up the scan process, so we tack on -- open. Now that requires root privileges. So let's switch user. Let's go from being a low priv user to a high priv user. And we can type sudo switch user or sudo su. And we'll punch in our password. And now we're root. Or we can exit out of that shell, go back to Kali, hit the up arrow, and just type sudo nmap -p-f $IP -- open. And we'll hit the return key. And this shouldn't take too long, but the point here is that we want to demonstrate what the output, that stuff right there, looks like for a variety of scans. In fact, what I'm going to do is say, I'm going to copy all of this. Right click. Well, actually, let's copy up through here. And I'm going to go into here, and we're going to open Cherry Tree. And I've got some targets here from Slayer Labs, but that's a different story. What we have is our template, and then I'm also going to add another thing here, and we'll call this lessons with Siren, right? And we'll hit bold and click OK. And then in that, we'll have a subnode, and we'll call it Metasploitable, we'll do that. Metasploitable 2 Nmap scans. We'll bold that and hit OK. And let's paste our data. Make sure that you're using monospace font. always go to File, and then go down to Preferences in Cherry Tree. And I believe under, where was it? Rich text, format, interface. Yeah, interface. Make sure that we have our font specifically set to a monospaced font. So type Noto Mono in here. Next to monospace, we're going to set that to Noto Mono Bold at 14 pixels. And rich text as well, we want that to be Noto Mono Bold. And the reason we want to do that is because look at that. See, now it's clean, it's in line, and it looks like it came straight out of a terminal. Then we're going to highlight all of this with Control A, and then use Shift Alt B to set the background to black so it's more legible, more contrasted, right? The eye sees things that stand out that are more contrasted, so you're going to see me do this as well a lot. Again, that's Shift Alt B, or Shift plus Alt plus B, and this is, and Shift plus Alt plus F, which I'm going to demonstrate next. The command will highlight Shift Alt F, select the color, and then, or we can add a custom color if we want. Select that, and now we have this highlighted, and Control B to bold it. Now that stands out a lot more, but that's a fragmentation scan. So we'll go here and we'll say this is a full port sweep. Well, that would be redundant because we're going to have that for many, but we'll say that this is a fragmentation scan as follows. And we'll put that, like, make that black. And then we'll have one for another type of scan. Just make sure you have something, however you want it. Really, it is semi-artistic, so, but it's artistic with a purpose, I suppose. And we can delete the MAC address. We're just going to stick to cleaning up and looking at our target here. But goodness gracious, look at all of those services. This is made exploitable, and each and every one of them, to my knowledge, is vulnerable. That's going to be fun. Let's do some more scanning. Let's get some more verbose information. So we've got our enumeration there stored away. That's another key principle. We've got our enumeration stored away. Let's, I can clear the screen and I still have it with an Alt tab. I can be in an engagement and I still, inside my virtual machine, I can be in an authorized engagement and boom. I just Alt tab straight to my notes. I can clear my terminal and everything is good. Excellent. So that's a fragmentation scan and a great way to check and see whether a firewall is stateful or stateless. But we'll get to that a little bit later in another, perhaps another module, what a stateful and stateless firewall is. For now, let's keep it simple. Nmap in plain English scan all 65,535 ports. Fragmentation scan to speed the process up. $, IP is an environment variable. -- open, we're only interested in those open ports. And all of these are respectively open. Now let's do nmap -p -sv at the target IP -- open. And this time we're going to speed it up even faster by tacking on -- min rate is equal to, say, 5,000. Heck, we could do 2,000. Let's do that. 2,000. We're not really too concerned about being detected by a firewall right now. Min rate equal to 2,000. And pretty shortly, now we're saying with -sv, you're gonna see in the output what's different is that we've got back our service version. So now every time Nmap identifies an open port, it's going to perform a TCP banner grab. And when it performs that TCP banner grab, we're going to get back the relevant service information. We can hit the return key at any time and see the process is 93.33% done. So almost done, almost completed. And this is an entire port sweep. You're not going to miss any vulnerable ports that are running up in the high-end red ranges, maybe a web admin port or something like that. You're not going to miss those ports by performing a -p scan. Heck, we can hit the return key again and see that, oh, it's taken quite a while. Well, that's what happens when you scan 65,535 ports and perform a service version check for each and every one of them. Because the next thing that we would logically want to do with service version information is determine the version number. The version number, dude. If we get the version number, we can cross-compare that with the exploit database, with CVE details, with proofs of concepts that exist for CVEs and weaponized code, exploits, etc., and potentially remotely execute code on the target machine, depending on whether or not it is vulnerable or not. So, with that all being said, I'm going to go ahead here and pause the video and resume it once the scan is done. And there it is. The scan is finished. Lo, my friends, behold, Metasploitable 2. This is it. This is what we're looking for. So I'm going to copy this. Actually, I'm really going to copy up through the command itself. And then we'll trim up some of this stuff here, but we're going to bring it over. Control V to paste it. We're going to get rid of that stuff up at the top where we were checking the status of how far along it was. Clean that up. Select everything. Scroll on down. Bold the back. It saves the color so you don't have to do it again and again and again and again and select that color. No, actually, it makes it very easy for you. You can just Shift-Alt-B and have that same background color. And then we'll highlight the scan, Shift-Alt-F, Enter. You get really quick at this stuff. And then Control-B to bold it. And boom. This is our service version scan. The service version scan. And look at all of the service versions that we've gotten back. We've got VSFTP, we've got an FTP server, an SSH server, a Linux server, a postfix SMTP, or Simple Mail Transport Protocol. We have a domain here, domain on 53. We have port 80, which is HTTP, Apache HTTP, daemon. See how we're getting the versions back here as well. 2.2.8. Already have the target operating system. Excellent stuff. We have RPC bind. So we can do like RPC info and get all kinds of RPC enumeration back potentially. Very potentially. 139, NetBIOS, SSN. You'll notice these are very important ports for enumeration information. 139 and 445, NetBIOS SSN. In this case, this is Samba. Samba is a service that is like Windows SMB server message block, but for a Linux or Linux-based environment. And it's saying, I'm not too sure. This is somewhere between 3.x and 4.x. We have exec, login, TCP wrapped. We could really go through this at great length, and we're going to break it down later. The point is, look at how much information we got back from the difference between our stealthy fragmentation scan, right? Just identifying which ports existed. Oh, this is FTP. Oh, this is SSH. Oh, this is Telnet. Oh, this is SMTP. This is domain. To now a whole new column of information, which is the version. That's the crucial point here. And yeah, we'll go ahead and move on to another scan. Let's scan it again in another way. I'm going to clear the screen. And we're going to say this time nmap dash, you can do a dash p dash dash sc. What is sc? In fact, what if we want to come, well, sc, we'll get to that in a second actually, but dash sc is simple scripts. So we don't want to toss, all the core scripts. We want to toss the simple scripts. So dash s, lowercase s, capital C. But dash sc at the target IP dash dash open dash dash min rate equal to 2000. Again, not really too concerned with detection here, just efficiency, right? Who knows, maybe for this engagement we were allow listed by their firewall and we're not even, like, why waste time then during the engagement? But there are stealthy ways of doing things as well. Modifying while this scan is going, modifying the scan speed with dash T, 0 through 5. I encourage you as extracurricular, definitely look into that. Or we can just do it on the machine at a later time. But dash capital T0, dash capital T1, T2, T3, T4, T5. So super quick to, this will take 2 days to complete, a very big difference. And again, we can hit the return key to examine the status. Can hit it again. It's chilling around 95.21% because it's identified open ports, and now we're running scripts. So there is a different type of information that we're also going to get back, a different degree of verbosity, if you will. I'm going to pause the recording, and then we'll just continue once it's done. And here we go. So we've gotten quite a bit more information back. My goodness. So we might not have gotten back the service version, but let's copy this and bring it over to our enumeration sheet to examine what difference we did get back with dash sc. Let's go ahead and highlight all of this. And we'll Shift Alt B. And then Shift Alt F, enter for the foreground, Shift Alt background, Shift Alt foreground. We'll bold this and call this simple scripts. So this is a simple script scan. Still all preliminary enumeration. Really can't stress that enough, guys. This is preliminary enumeration. Like, dude, this is the stuff I would expect back easy peasy, done quick. But like nice and clean too. Like there's the checks on how long it was going to take, or how long it was until it was finished, removed, and we'll clean up stuff as we go. But nonetheless, here we are. So simple scripts. Look at this. There's a difference between dash SV, service version, and dash SC. And that is that we're getting back script info. So it's going to check in, to FTP. It's going to say it logged into FTP. That means anonymous. Out of the gate, we have a finding with dash simple scripts, which is that anonymous login is permitted on the target machine, right? On the remote machine, FTP is open on port 21, and it's allowing anonymous as the username and anonymous as the password as a login. Yikes. Well, we're going to be able to exploit that later. What about 22? We got back SSH host key information. And what about 25? In that mail server, we got back all the protocols like Netcat Chat, but we can send along, size whatever, VRFY, ETRN, start TLL, or start TLS. This is just protocol, right? So, or client server protocol. And we also got back a bunch of other great information that we could go through in great detail. Don't worry, you know me. You're with us here at Startup.Security, and you're with Siren. We're going to go over all of this information in great detail. But look at the different types. Up here, we have the actual service that's running on the machine, alongside the version information. Down here, we've got the script information. This is the core difference right here. This is the core difference, right? I'll highlight the core differences for you. This is the core difference. Whereas up here, you know, I'll highlight the first few. We get back version information, service version information. And you can highlight the rest if you want, but you get the point. Not present down here, but what is present down here is a lot more goodness. Heck yeah. Ciphers. The bind version of DNS, 9.4.2. Like, this is really good stuff. MySQL capabilities. This is really, really good stuff. And you just see me highlighting that script output. That's all I'm doing. All I'm doing here is highlighting the script output. And that helps it stand out. You know, the objective, the point of the scan. And then for 139, this is ports 139, and 445, SMB, right? Well, we got back all of this. Samba 3.0.20 Debian, like, it's hard for me not to dive in just yet, but we're going to continue forward because there are other Nmap scans to cover. So that was goodness gracious, we've covered a lot of different Nmap service scans, script scans, fragmentation scans. Yeah, we've covered a lot, but let's go ahead and clear this. So yeah, let's check out a new type of scan, one of my favorites, -p-a at the target IP --open. And what we're saying here is go ahead and cover all scripts. Well, not all scripts, dude. Kind of like all scripts minus the brute forcing scripts, right? Because if we get rid of the brute forcing scripts, then we're really not taking an unnecessary amount of time doing a whole bunch of just unnecessary crap, right? We're looking to be surgical here, and if we're permitted to do a script scan, well, then guess what we're going to do? We're going to toss something like -a at it and watch the output we get from -a. I'm going to pause the recording and resume it as soon as this output is done. All right, so let's take a look at this. This is -a. -a, we'll copy all of the output in completeness over here to copy, right click, copy, alt tab back into cherry tree, you know the drill, paste it in, select everything. I'm gonna scroll down. We'll select everything down here. And we'll hit Shift-Alt-B for the background. And also, yeah, so we'll go up here and bold our scan itself. It's good to know these by, why am I spending so long on this particular topic? Because you guys in my streams, you may see me do these like really, really quickly. You got to know the thinking behind why I'm doing it the way I'm doing it, right? That's what you're here for. Because if you understand why I'm doing it the way I'm doing it, your chances of success at passing offensive certifications are going to go through the roof. I don't know any other way to put that. So nmap -p-a at the target IP --open. This is single target enumeration. This is an aggressive scan. So here's your aggressive scan, right? Shift-Alt-B. And, you know, we'll highlight this as well. Bold that. This is an aggressive scan, -a. In fact, we can even, look, you can change colors. Like, what if I want this to be, I don't know, bright blue, a vivid blue color. You can select that. And yeah, you know, we're talking about the -a flag. Cool. What if I want it to be somewhere in the spectrum? I could type, or put in, have dash A and put in an orange. This dash A is what we're looking at. Or I could make it more of a yellow color. Like that, and it'll stand out brighter. Anyway, the point is, this is useful. You want to have at least 3 shades because you're going to be breaking down the service versions, right, and the running service, and you're going to be breaking down the script output. So I may, for the sake of visibility, Shift-Alt-F, and you'll see me do this throughout the course and set it to a red color for a version number, critical numbers, and the service. And then when it comes to the script output, you'll see me Shift-Alt-F and select kind of like a yellowish orangish color, and see how that makes things stand out a lot more cleanly, as if it was in a terminal with color coding. And the beauty of all of this is that your work is not in vain. You can save all of this as HTML output to be able to, well, learn from, or maybe it's a report that you're putting together, like technical documentation. I forgot a little bit down there. There we go, end of status. And, there's all the script output. And similarly here, we have SSH. You'll see me do this just to get the point across. We have open SSH. Why do I highlight what I'm highlighting? I'm highlighting the lowest hanging fruit, and this is something that comes with time. For now, we're just going to look at it as it is. The big pieces that need to be highlighted. Open SSH 4.7 P1. Debian. Oh, well, that's something that stands out, right? Bold that. We already just got the target operating system information. More specifically, that it's Ubuntu on top of that. Ubuntu 8. We just got target operating system information. I'll bold that out, So anyway, moving along, this is an aggressive scan, and we expect to get back pretty much maximum verbosity. That is maximum verbosity on our stuff. And I'm just going to go through, highlight this stuff here, and continue to highlight, very basic highlights at the start. Why do I highlight? It's really quite simple. The reason I highlight is because in my enumeration, Markdown is great. Don't get me wrong. Just clean, plain text, Markdown, or not plain text, but Markdown is great, but it's not going to give you the coloring options. It's not going to give you italices, boldness, underlines. It's not going to give you more control over those types of things. And when I'm scanning down, I don't know about you, but when I'm scanning down 200, potential up to 254, 255 machines, goodness gracious, I don't want to have all of this be white text. Could you imagine if I was scrolling through all of this and it was just white text? Things don't stand out then. I can't jump back into the engagement quickly, or I can't pass these on a red team. I can't pass these notes and say, hey, here's the cherry tree file of my enumeration, and they can import the file and have everything and just kind of scroll through it. So this is just part of my methodology, guys. This is just part of it. And yeah, it will lead to your success. That's what it does. And eventually you'll have to do these kind of things less. They'll become like second nature. And then we'll drill in even further. And I made the background there the wrong color, but Shift-Alt-F and set that to a red. And do the same thing here, RPC on 111. Shift-Alt-F, make this a yellow for the script output. And now we have our script output and our service version output highlighted. Now there's more to this, and there's a lot more fine details that we're going to be assessing. I mean, you are in for a very serious thing, and this is only one machine. We have planned labs that we would like you to go through, and I'll be right there beside you throughout this entire course, doing it alongside you. It's going to be really awesome. I hope that, and this is something you can pause, you can rewind, and yeah, you'll be going into OffSec certifications locked and loaded for bear. You can even trim this stuff up if you really like host is up, how many ports, not shown 65,505. Like, look at this, we can clean this up, whatever makes it easier on the eye, right? Think from an accessibility standpoint. You want your port in my Nmap output. I want my port, state, service, version, and script scan output. Ideally. And then we're not done. We can keep scanning this. And there is even still one last and final scan that I would like to show you. Type clear. And we're gonna throw everything in the kitchen sink. This is the loudest possible scan you can possibly think of. This is like dropping a 500 kg bomb onto a target machine in terms of traffic and information, but it is nmap -p -script is equal to vuln at the target IP, and we'll say -- open. And we're not going to touch the min rate because this is working with vulnerability scanning. We're going to leave it we're going to leave it just as is. And you don't even have to run this if you don't want to, if you don't want to sit around and wait. But I encourage you to if you have the time. In fact, you should have plenty of time. But yeah, let's go ahead and run this. You know the drill. I'm going to pause the video and then resume it respectively once we are done with and we have all the output. Okay, and now our -- script equals vuln scan is done, and well, you'll see that we've gotten quite a lot of things that it is already, look at this, vulnerable to this, vulnerable to that, vulnerable to this, and vulnerable to that. Goodness gracious. Goodness gracious, this is awesome. Okay, so we're gonna copy all of this, bring this one over. This is -- script equals vuln, and we're gonna type nmap -- script equals vuln. So it's a vulnerability scan. Everything in the kitchen sink, and this actually needs to be background black, my bad. And then we'll select the black color and just continue on our way. We go ahead and paste. Oh, it didn't paste. There it goes. It was just a lot, but there's the paste. And let's bring this down all the way. Imagine having to look at all of this and it just being plain old white text. Wouldn't be able to really see anything. This is the kind of thing you'd really want to take an hour and just go through it and have a separate file of your forensics on this particular scan, right? Because that's like what we're talking about with this methodology. It's a lot like forensics or aggressive, maybe offensive forensics, but taking all of this information, and you can see now why maybe I am interested in highlighting certain aspects as critical or certain aspects as, I need to be able to check this out and manually inspect this, or script output, or service version output, or vulnerability, inclinations and stuff like that that could become relevant. We Control Alt B to set that to a black color with the black check mark and hit select. And that is excellent. That is wonderful. That is great. And that's pretty much going to conclude this module. There is, however, one more thing that I wanted to tack in here. So here's our thing. Let's go ahead and make sure we color this off as that bold red that we love, and select this, just so you know we have our scripts at least separated, our script scans separated. And I mean, heck, maybe there's multiple machines, Maybe you want to segment all of this information and know when a new machine begins and when an old machine ends, or something like that, right? So you just hold down the equal sign. This is what I do. And add what's known as a separator, right? And then you just copy this. You can give this a orange color, or you can give this like a blue color, right? Select and Control B to make it extra bold. Remember, this is a separator. Get it as wild as you'd like. If you want it to be like this, you could, it could be like that. However you like. But this is known as the separator in our notes. And we'll scroll up to the top of the next output. And when we scroll across everything that we've pasted here, you'll see how much easier it is and how much more things kind of just stand out. Even adding a little spacing between machines is always useful as well. But you'll see kind of how much nicer. Now take a look at all the different scans that we've done. Pretty nice. Now we could have kept highlighting all day, but imagine if this was different machines. So this is part of, my network enumeration and a little bit about my notation as well. And we'll get into that later for the single target machine. And we'll also talk more about our template itself. Don't think I forgot about that. Many of you from my streams know that I use this template. It's not going anywhere, and we're going to be utilizing it as well. But before we wrap up, let's use Netcat to perform a simple connection to the target server, right? Let's say we want to examine now our first bit of manual enumeration, and we want to verify whether the user root is a valid system level user. That means kind of like this. We're going to conclude with a Netcat connection on port 25. And all we have to do, and I'm going to open Wireshark on this. And this time I'm going to select, I'm going to select any here. Or do I want, let's go ahead and select any. And then what I'm going to do is type nc-nv to the target IP on port 25. And now we're connected with Netcat. And we're going to type VRFY, or verify root. And when we hit the return key, notice that we get 252.2.0.0 root back. We just performed an extremely low-level, bare-bones connection with Netcat alone, and have already enumerated a critical system-level user, which is the UID equals 0 user. Notice if I have to type in VRI, a system-level user, verify this user doesn't exist, it's going to say recipient address rejected, user unknown in local recipient table, therefore and thereby root exists on the machine. So we can hit Control-C to escape out of that. And you'll see here in the activity, I'm going to pause the recording, but you'll see here in the activity, amongst ARP information and whatnot, that we have, look at this, in the info, verify this user doesn't exist. Or verify root. What if we right-click that? Follow. TCP stream. Look at that. It's just like our Netcat chat, right? Just like it. We have a connection to the server, and a server responds with a header or a banner. 220 metasploitable.local domain, ESMTP postfix, Ubuntu, ready. And then we say, okay, VRFY root. Verify root. Does the root exist as an account? And it responds 252.200 root. That means it does exist. We know that the root level account that we're going to be going for, and we're going to be getting through a multitude of avenues, hopefully, right, exists on the target machine. Additionally, verify this user doesn't exist, and we've already done some preliminary SMTP enumeration, or not web, but mail enumeration on the target machine. And it is all in your enumeration, guys. Everything we're going to really be teaching, a vast majority of it is enumeration and how to enumerate your target to make sure that you're, getting to the nitty-gritty of the lowest hanging fruit. So we'll clear that out, and I will make sure to catch you in the next module. Peace out, guys.